The short-tail stingray. You've probably waded past one without knowing. These rays lie flat, buried in sand, completely invisible, which is why the beach shuffle exists. Steve Irwin pulled the barb out himself. Minutes later, he was gone. And the reason why wasn't the venom. Short-tails grow to 7 feet across and 770 pounds, the largest stingray species alive. The barb is serrated keratin with a venom groove, but the venom's almost beside the point. The barb's a mechanical spike. A human chest wall is about 2 inches of tissue. A short-tail barb drives 10 inches deep with full strike force. Irwin's went through wetsuit, sternum, and heart in one upward stroke. That barb evolved as defense against sharks coming from above, and the upward reflex is tuned for that exact vector. When Irwin swam over one, the ray triggered a response built for a tiger shark, and it didn't know the difference. Evolution handed it a shark-specific panic button, and nobody told it clumsy humans press it harder than sharks ever did. Stingrays don't attack. They strike only when something's directly on top of them. Most ocean deaths in this video take venom, toxins, and chemistry. This one took 2 inches of sideways force and a heart in the wrong place. It's one of the rare creatures where stepping on it turns out to be the best outcome available. The Portuguese Man-o War. You've swum past one without noticing. The float is often the only part above the surface, a translucent blue bubble the size of a fist, while the tentacles vanish into the murk below. It looks like a single animal. It isn't. The float is gas-filled, up to 12 inches long, and the tentacles can trail 100 feet beneath it, longer than a blue whale. It's a siphonophore, a colony of 4 types of specialized organisms called zooids, all working as one. Each tentacle is lined with millions of nematocysts, coiled venom harpoons that fire on contact. They fire even after the animal's dead. A tentacle washed up on the beach is still armed. A Man-o War's tentacles can reach 30 meters down from a float the size of a child's fist. One animal dragging a stinging curtain longer than 10 parked cars end to end. It's an animal that outsourced its own body parts. Imagine if your liver was a separate creature that lived with your lungs, and neither could survive alone. Most sting survivors recover with severe pain, but for children, small bodies, and anyone cardiac vulnerable, severe systemic stings have triggered cardiovascular collapse within minutes. You're not looking at an animal. You're looking at a committee that votes unanimously every time to kill you. The Reef Stonefish. Snorkelers and tide poolers step on them every year. The camouflage is so complete that even trained divers can't tell one from the rubble around it. Victims have one request as they're carried off the beach. The ER usually has to refuse it. Reef stonefish carry 13 dorsal spines loaded with venom sacs, and they're the most venomous fish on Earth. They hunt by ambush, sitting motionless for weeks. The first contact you make is your foot on its back. By the time pain arrives, 13 spines are already in you. Documented victims have begged medics for amputation within minutes, not because of the wound, but because the pain reaches a ceiling no opioid can touch. Stonefish pain overrides maximum dose opioid analgesia. Victims ask to have the foot cut off inside the first 10 minutes. The stonefish's hunting strategy is be a rock. The defense strategy is also be a rock. Evolution found one good idea and refused to leave the room. The puncture itself isn't lethal. The venom is a cardiotoxic protein cocktail. Victims don't die from the wound. They die from the heart attack the venom triggers. The most venomous fish on Earth never chose to be venomous. It wanted to not be stepped on. And 13 spines plus a cardiac poison was evolution's version of a polite request. The ocean doesn't need teeth to kill you. It just needs patience. The textile cone snail. Tourists collect these on Pacific beaches every year. The shell is stunning. Intricate brown and gold patterns like woven cloth, which is where the name comes from. Holding one closed in your palm is the part people regret. There's a reason this snail's nickname is the cloth of gold, and a reason experienced collectors wear gloves. Textile cones reach 6 inches and live on Indo-Pacific reefs. Their delivery system is a harpoon-like radula tooth fired from an extendable proboscis, faster than the eye can track. The snail moves at roughly an inch per minute. The harpoon moves at roughly 400 millimeters per second. The slowest hunter on the reef makes the fastest strike. Human reflex time is about 250 milliseconds. The strike lands in under 200. The shell has already injected you before your nervous system realizes it moved. An animal whose hunting strategy is be a very nice paperweight, and whose backup plan is instantly. Textile cone hunts other mollusks, which means its venom is optimized against the exact nervous system type that also runs in octopuses, squid, and, inconveniently, humans. Cone snails aren't slow prey waiting to be picked up. The shell is the trap. Only 2 cone snail species have confirmed human kills, and this is one of them. They just require the shell to close in your hand. The Irukandji Jellyfish. Swimmers in tropical Australia enter water they've checked for box jellies. Irukandji slip through every net. The sting is often not felt at all, and there's no welt to find. You don't know you've been stung until the symptoms hit 30 minutes later. Doctors have a specific medical term for what these victims experience. It isn't anxiety. It isn't panic. It's clinically described as a sense of impending doom, and it's one of the criteria used to diagnose. Irukandji bodies are about the size of a thumbnail and weigh less than a dime. The venom triggers Irukandji syndrome, which involves severe hypertension, tachycardia, pulmonary edema, and psychological dread. A standard jellyfish you'd worry about is the size of a dinner plate. Irukandji is smaller than your fingernail, and it hospitalizes adults with doom-level panic attacks inside 30 minutes of a sting they never felt. Scientists know what the venom does. They know it works. They still can't fully explain why the brain interprets it as existential dread. Somewhere in nature's chemistry, there's a molecule whose side effect is philosophy. Irukandji aren't deadly because of their size. They're deadly because the venom targets the cardiovascular system differently than any other jelly on Earth. Every patient describes the same feeling in the same words. The venom isn't causing the fear of death. The venom is the fear of death, written in chemistry. If you're the kind of person who geeks out over this stuff, I post new wildlife deep dives like this regularly, and subscribing genuinely helps. Thanks. The Flower Urchin. Divers and snorkelers run into these across Indo-Pacific reefs. They look like bouquets, pale pink and white petal-shaped pedicellariae blanketing the shell. People reach out to touch them, and they always regret it. Guinness holds a record for this animal. It isn't the one the flower suggests. Toxoneustes pileolus holds the Guinness World Record for most venomous sea urchin. Those pretty flowers aren't decoration. Each one's a miniature biting jaw on a stalk, and hundreds cover the shell. A single touch triggers dozens of contacts at once. One pedicellaria delivers a thimble of paralysis. Dozens of simultaneous stings is enough to take down a pearl diver. Reports of drowning deaths trace back to that math, with victims paralyzed in open water and nobody there to hold them up. The pedicellariae inject a glycoprotein paralytic on contact, and documented symptoms include facial paralysis, respiratory distress, and complete loss of muscle control. Nature made something that looks like a bouquet and functions like a minefield. The marketing department had no idea what the engineering team was doing. It's the only flower arrangement that sends you to the hospital. The most venomous sea urchin on Earth doesn't hide. It sits there in plain sight, looking like a spring garden, and your only defense is being the kind of person who doesn't pick flowers. The geography cone snail. This is the second cone snail on the list, and it earns its own slot. Textile cone kills. Geography is in a different league, more lethal, more prolific, and the subject of more pharmaceutical research than any other marine species on Earth. Divers call it the cigarette snail. Gallows humor wrapped around the implication that you have time for one smoke before it's over. The sting is usually felt as a pinprick. Paralysis is the next thing the victim notices. Conus geographus has roughly a 70% fatality rate in untreated human stings. A single snail's venom contains 100 to 200 distinct conotoxins, and the species produces more than 700 unique compounds. It's also the source of ziconotide, an FDA-approved painkiller 1,000 times stronger than morphine. The FDA spent a decade approving a painkiller the snail figured out with no clinical trials and a lifespan of about 6 years. The geography cone didn't evolve the world's most complex venom to kill you. It evolved it to kill fish. You're a side effect. The fact that you die too is a rounding error in the snail's business model. The slowest predator in this video has the fastest kill. That's not a coincidence. That's an arms race settled by chemistry. The Beaked Sea Snake. Fishermen in Indo-Pacific waters pull these up in nets every day. The bite is nearly painless, and some victims don't realize they've been bitten until systemic symptoms begin. Most snake bites announce themselves with pain. This one doesn't. The first thing most victims feel is their own muscles failing. Beaked sea snake venom is 4 to 8 times more potent than cobra venom. A lethal dose is 1.5 milligrams, less than a grain of salt. It causes neuromuscular paralysis, respiratory failure, and rhabdomyolysis. Sea snakes deliver dry bites, no venom in most defensive strikes. When they do envenomate, the dose is so concentrated, the lethal amount is invisible. A grain of table salt weighs about 60 milligrams. A single yield from one snake can kill dozens of adults and still leave venom to spare. The deadliest part of this snake isn't the bite. It's the fact that you might not bother to go to the hospital. Sea snakes descended from terrestrial elapids, and the venom got more potent, not less, as they adapted to water. It's a snake that evolved to live in the one environment snakes are arguably worst at, and became better at killing than the ones that stayed on land. If the bite were painful, these snakes would be famous. The silence is why they aren't. The Australian Box Jellyfish. This is the animal every Australian lifeguard trains around. It's the reason northern beaches close for months of the year. Swimmers who ignore the warnings have died before reaching the sand. There's a specific stat about this animal that made headlines. The number sounds like a typo. It isn't. Chironex fleckeri carries up to 60 tentacles, each up to 10 feet long, each lined with millions of nematocysts. A single specimen carries enough venom to kill 60 adult humans. Documented cardiovascular collapse and death have occurred in as little as 2 to 5 minutes from severe stings. Death in 2 minutes. For context, that's less time than it takes most people to finish brushing their teeth. The ambulance that arrives fast is still arriving to a different kind of patient than the one who called. This animal has 24 eyes, including complex image-forming ones. It can see, it can steer. It hunts fish actively. It's an ambush-capable invertebrate with venom tuned to stop vertebrate hearts. Evolution built a fully autonomous weapons platform and covered it in clear jelly. 2 minutes isn't the time the box jelly takes to kill you. 2 minutes is the time between when you hit the water and when you might not have a pulse. The sting is instant. The countdown was already running. The Blue-Ringed Octopus. Tourists pick these up in Pacific tide pools every year. Kids in Australia grab them because they glow. Every one of those moments is a bet against paralysis, and the house always wins. There's no antivenom. There has never been one. The reason isn't funding or research, it's chemistry. The bite is painless, and that's the worst part. Hapaloclina lunulata is the size of a golf ball. Its venom contains tetrodotoxin, 1,000 times more potent than cyanide. A single individual carries enough to kill 26 adult humans. The first symptoms are tingling, then respiratory paralysis. The victim stays fully conscious throughout. Treatment is ventilator support until the toxin clears on its own. We can't make antivenom because tetrodotoxin doesn't have an antibody-friendly structure. Biology can't build a shield for something chemistry shouldn't have produced in the first place. The bright blue rings only flash when the octopus feels threatened. Their evolution's don't touch sticker. And the venom is the consequence when the sticker gets ignored. Blue rings aren't aggressive. They bite only when handled, and tourists pick them up constantly, thinking they're colorful toys. An animal the size of a golf ball, paint courtesy of a rave flyer, carrying enough venom to take out half a crowded elevator. You don't feel the bite. You feel your fingers start tingling. You feel your tongue go heavy. And then, fully conscious, you feel your own breathing stop. The smallest animal in this video closes the video by being the only one that lets you watch yourself die. If you made it this far, subscribe. I post more deep dives like this regularly, and it's the easiest way to catch the next one. Thanks for watching.